Welcome to APR Supplies, Tech Tips for the Pros. Today's discussion will be about saturation.
Saturation is the temperature the refrigerant boils at based on its pressure.
The boiling point of the refrigerant is something that we're going to manipulate by way of the refrigeration system. This is what allows us to actually cause refrigeration to occur. Right now we have this cylinder of refrigerant 410A, and as I look at the gauges, it's registering 225 pounds, and that is the temperature, the saturation temperature of 77 degrees. At 225 pounds, it will boil at 77 degrees. The reason this is important is we can't see what's happening inside the refrigeration system. We have to use these numbers, superheat, subcooling, and saturation temperature, to understand what's happening in the system. Our goal is to take that inside coil and fill it with boiling refrigerant. And we put some soap in the water just to show what it would be like. We want to fill that with boiling liquid refrigerant. That's all. The boiling point is where it's absorbing heat. But our coil is copper. We can't see it. We can't see where the level of the liquid is in there. So to find that liquid level, we have to go back to the saturation point. What we're going to do is measure the pressure of the refrigerant in the coil. And then we'll measure the temperature of the refrigerant in the coil, and we'll reference that to the saturation table. All of the saturation tables are available in both card form as well as on your digital gauges, and it's also available on your analog gauges. Now what we're going to do is we're going to take this bottle of 410A, and it's right now at 225 pounds, and at room temperature at 77 degrees. Now I previously measured this water at about 109 degrees. So I'm going to take the bottle and I'm just going to put it into that 109 degree water, and as I leave it in there, it will start to raise its pressure as well as its temperature. After putting the 410A into the warm water, the temperature is rising. The saturation temperature is up to 84 degrees, and the pressure now is up to 252 pounds. As you can see, as the temperature changes, the pressure changes. That also is true in the reverse. And that's what we do with the compressor. We're going to raise the temperature of the refrigerant by raising its pressure. So in the outside portion of the air conditioner, we're going to raise the pressure, raise the temperature, and now that hot gas, we can reject the heat into the outdoor air and allow that refrigerant now to liquefy, because we'll be able to bring the outdoor air past it and lower the temperature till it's below the saturation point, and it will liquefy. So in the outdoor unit, when we have the high pressure, high temperature gas, and we blow the air past it, reject the heat, and it comes to the saturation point, and then every degree that it cools below the saturation point, below the boiling point, it is more subcooling, and it's proving to us that we have a liquid refrigerant. Have you ever been able to drink a subcooled liquid? Think about coffee. When you get it when it's hot, it's still below 212 degrees. 212 degrees is the boiling point. 212 degrees is the saturation point of that liquid. And as any temperature below the saturation point occurs, it becomes subcooled. The other side is superheat. After it's boiled off, we measure the temperature of the refrigerant, we measure the pressure of the refrigerant, and then we're able to calculate what the boiling point was, what the saturation point is, and how much warmer it is than saturation. Temperature above saturation is superheat. That's how we'll measure to make sure that when the refrigerant returns to the compressor, it's a gas. Thank you for watching APR's Tech Tips for the Pros. Hope to see you again soon.